Welcome to the DAN Europe Dive Safety Laboratory Advanced Module. The purpose of this Advanced Laboratory module is to show some of the additional research initiatives that are performed as part of Dive Safety Laboratory and supported by DAN DSG, but extend beyond the basic research protocols of diving data collection. Just as a reminder, in terms of the overall organization of DAN Europe research, all DAN research subjects are enrolled as DAN research divers. These individuals have agreed to submit their diving details and electronic dive profiles to DAN research. Once they are registered on the DSG platform, they can upload their dive data themselves. Alternatively, DAN research operators are registered and trained to allow them to upload diving information and electronic dive profiles on behalf of DAN research divers. This method is also very suitable for diving instructors who may do so on behalf of their students and thereby have access to the diving details for the purpose of safety surveillance and training quality assurance. DAN research technologists are trained to record post-dive precordial Doppler signals in addition to recording diving information and uploading electronic dive profiles. DAN research specialists receive additional training on how to appropriately process and upload the Doppler recordings. And lastly, the DAN research coordinator oversees research efforts being conducted in their respective regions. The DAN Europe Advanced Diving Safety Laboratory techniques are reserved for coordinator, specialist, and technologist levels. The reason for this is because the tests involve working with body fluids like blood and urine, and therefore special training is required, as well as registration with the institutional review boards who oversee the ethical aspects of this research. Diving involves many physiological and psychological stresses, and each of these poses a potential risk to the participants. And so, to fully understand the various factors affecting diving safety, various research methods need to be employed. One of the unique aspects of compressed gas diving is, of course, the decompression stress and the potential for bubble formation. However, studying diving safety purely from the point of established decompression illness has two significant limitations. Firstly, the number of divers who develop clinical decompression illness is relatively low, which means that many thousands of dives will need to be collected before any cases of DCI emerge. And secondly, a study of DCI cases would not permit a comparison of the relative safety between different decompression schedules that don't produce clinical symptoms, and ideally to prevent it from happening in the first place. Put differently, if we were to wait for divers to develop decompression illness before studying the risk factors involved, we would wait a very long time. And even then, we would still have no way to compare the relative safety of different exposures that don't result in decompression illness, or to offer suitable safety advice. So the point is this: we cannot only use clinical manifestations of decompression illness as a diving safety outcome measure. So the question is then, what markers can be used to determine relative decompression stress and diving safety? It is commonly agreed that the detection of venous gas bubbles after diving is a reasonable marker of decompression stress. Although the presence of such bubbles does not necessarily predict the development of decompression illness, the absence of bubbles does carry a very low risk for developing decompression illness. As such, it is reasonable to pursue diving methods and decompression profiles that lower the incidence of post-dive venous gas bubbles. In general, there are two different types of investigations that may be used for the detection of decompression-related bubbles. Doppler ultrasound assesses blood flow and can detect bubbles traveling in blood because of their specific acoustic properties. This type of assessment may be used to record bubbles within the pulmonary artery, also called precordial Doppler, recording venous gas bubbles in a vein below the collarbone, called subclavian Doppler, and even detecting bubbles in arterial blood in the neck, called carotid Doppler. Alternatively, bubbles may be visualized by means of a different application of ultrasound, of which echocardiography is the most relevant to diving. This assessment of the heart allows gas bubbles to be detected inside the heart, in other words, so-called silent bubbles, and the probe may be placed either on the outside of the chest, in which case it is called transthoracic echo or TTE, or the probe may actually be passed down the esophagus right behind the heart, which is then called transesophageal echo or TEE. At present, DAN Europe uses only precordial Doppler and transthoracic echo as part of the advanced DSL research program. An important aim of the Advanced Diving Safety Laboratory is not only to perform these various relevant assessments, but to make it so practical that they can actually be performed at the dive site, in the field, not only in formal research settings. As far as possible, DAN research also involves volunteers to assist in gathering data. However, to ensure that the data is recorded ethically and is of high quality, extensive training is required with expert supervision. The following tests have been included in the Advanced Diving Safety Laboratory. For bubble and hydration assessment, urine density, hemoglobin, hematocrit, and bioimpedance. For bubbles and body temperature, thermal camera monitoring. For bubbles and genetic predisposition, DNA testing. And for bubbles and the interaction with blood vessels, specifically related to nitric oxide, flow-mediated dilation. DAN Europe's Doppler protocol makes provision for recording of precordial Doppler. This is a typical example of the outcome of research conducted by means of this protocol. This slide shows that out of 2,438 samples of post-dive Doppler recordings, the vast majority had either no bubbles or low bubble grades. DAN Europe's DSL echocardiography protocol is used under special circumstances. It becomes particularly relevant when it is important to not only detect the presence of bubbles, but specifically to confirm or exclude the presence of bubbles in the left ventricle of the heart. Here's a typical example of the outcome of 744 dives assessed using this methodology. The dive profile itself, that is depth, time and ascent, is not the only important factor in determining post-dive bubbles, however. It is well known that dehydration prior to diving is a potential risk factor for decompression illness. As such, monitoring the concentration of urine is one simple way to ensure that divers are aware and deliberately take steps to ensure adequate hydration. As a result of the findings of this research, DAN Europe is actively advocating a More Water, Less Bubbles campaign. It is possible to go several steps further, however. Urine concentration can vary greatly due to the diuretic effects of immersion. As such, it is valuable to also assess blood or hemoconcentration. This test examines a sample of blood in a capillary tube to determine the fraction of cells relative to plasma. A greater concentration of cells relative to plasma can indicate dehydration or hemoconcentration. To further add to the accuracy and specificity of this test, assessing the concentration of hemoglobin, that is the red pigment in red blood cells, allows greater refinement and can also indicate stress responses to diving. In addition, using relatively simple devices such as this bioimpedance monitor, it is possible to determine body composition, including cell, muscle, fat mass, and body fluids, for the purpose of relating these to bubble formation and overall diving safety. Changes in temperature are also relevant to bubble formation. These can be studied non-invasively using thermal cameras before and after diving. Processing these images offers a simple measure of central body temperature changes, which can then be correlated to other markers of decompression stress. Genomic information, in other words, information related to an individual's DNA, is becoming extremely accessible and ever more affordable. These assessments allow the identification of individual risk factors for bubble formation, blood vessel responses, and inflammation. Flow-mediated dilation is a test that uses the Doppler ultrasound method to measure the diameter of the arm artery, that's the main artery in the upper arm, before and after a 5-minute forearm compression test using a blood pressure measurement cuff. The average diameter of the brachial artery is about 4 to 5 millimeters, and after the 5 minutes of occlusion, the flow through the artery increases, and the artery diameter increases to about 7 to 10% greater values. This is called flow-mediated dilation. So the response of blood vessels can be measured using this test, and it gives an indication of the responsiveness to various physiological signals, especially nitric oxide. These various specialized assessments represent innovation, offer the opportunity for individualization, and allow us to make ever more refined interpretations as it relates to diving safety. One such innovation includes the customizing of ultrasound equipment to perform precordial Doppler and ultrasound assessments while still underwater. The recent development of real-time blood glucose monitoring devices has now been expanded for underwater applications. This means that instead of doing pre- and post-dive blood glucose assessments in diabetics, it is possible to monitor blood glucose changes throughout the dive. These are just two examples of the ongoing innovation related to DAN Research Advanced Diving Laboratory. DAN Research is committed to continue adapting and refining the ways in which diving safety may be studied, monitored, and improved. It is not an individual effort. It is an interactive collaboration between DAN Research and the diving community. The goal is not only to collect the data at the dive site, but to actively involve divers in obtaining it. The key is involvement, as well as meticulous interpretation. The initiatives and findings of DAN Europe's Advanced Diving Research Laboratory can all be captured using the Diver Safety Guardian platform. This level of access is made available specifically to DAN research technicians and specialists upon registration and completing the relevant training. We would like to remind you, however, to please invite all divers to be registered with the DSG online platform and to enter whatever level of research data they are able to contribute. The fact that sophisticated tests are available should in no way discourage divers from simply submitting their diving history and electronic dive profiles. This is where it all starts, with the more sophisticated tests being added as trends and findings emerge. Thank you for supporting DAN and for being part of this diving safety initiative.